In this, we will see about the design and simulation of single-phase differential boost inverter for induction motor drive. In this, we are using a differential boost inverter for driving the induction motor. And here in the input voltage source, we are providing 12 volt. In this side, we are having one boost converter. In this side, we are having one boost converter. Both combined, it will form a dual boost converter. So the load connected across these two converters will have the voltage that is combined by these two boost converters. In this, if you see, means here it will be boosted using when the switch is on, this inductor will be boosted, and when the switch is on, this inductor will be boosted here, and the output of this will be provided here to this capacitor to this switch. This switch will operate when the switch is not operating. So at the time here this inductor and this voltage source will get added. So the output voltage will be input voltage plus inductor voltage. Similarly for this capacitor, same thing. Input voltage plus inductor voltage is equal to this capacitor voltage. The difference in these two voltages are combined across the load so that we will get differential output voltage. So if we make it, this side will act on the positive cycle and this side will act on the negative cycle. We will get a inverter output voltage across the load. That is, the differential voltage will be AC voltage. This can be easily explained here. First one is the right hand side capacitor voltage. This is boosted from 12 volt to 200 volt. Similarly, the second one is the voltage across the left hand side capacitor. Here from the load point, this one it is in negative. So both if we combine, we will get a sinusoidal waveform at the middle. That is the differential voltage will be sinusoidal output or AC output. Here the capacitor should be properly designed in order to get an AC out, that is sinusoidal waveform. We are simply combining two boost converters, and in between that we are creating one load, that is differential load. So across the differential load, we will get the differential output voltage, the difference in the between the right hand side and the left hand side converters. So from that voltage, we will get the AC output, and from the AC output, here we are connecting the motor in order to run that AC induction motor, single phase AC induction motor. So here the speed is initially slowly increasing, and here it is increased up to 156 radian per second. The torque is 0, and this is the output voltage and the current. The output voltage is around 200 volt and current is around 2 amps. The THD we are getting it as 11.06%. If we properly design that capacitor, we can get the output voltage. Otherwise, we have to create one filter across the load. Here this capacitor is designed according to the boost converter design. So it will concentrate on the boost output only. Similarly, this capacitor. For filter, we have to separately design. Okay. This is the working. That is, we are connecting a 2 boost converter and to a source. And in between that, we are connecting one load to create the differential voltage. The differential voltage will be AC when this converter operates only for positive cycle, and this converter will operate on only for negative cycle. In positive cycle, this side converter will not operate. In negative cycle, this side converter will not operate. So by creating this, we are creating one differential output voltage that will be shown across the load. And here we are connecting one single phase asynchronous motor. So this motor will be controlled by this inverter. This motor will be driven by this small inverter.